All right, let's talk about a really cool, kind of radical idea in the world of connectivity. We're talking about networks that literally build themselves. No central tower, no fixed cables, and get this, no boss. These are Mobile Ad Hoc Networks, or MANETs. But why would we ever need something like that? Well, let's put you in a situation where it all makes sense. So picture this, you're hiking, way out in the middle of nowhere. Or maybe a huge storm has just rolled through and knocked out every single cell tower in your town. You pull out your phone, but you've got no bars. It's basically a brick, right? Well, that is the exact problem MANETs were born to solve.
In the most high-stakes situations you can imagine, we're talking military operations, search and rescue missions after an earthquake, you just can't count on traditional networks being there. They might not exist in the first place, or they might be completely destroyed. In those moments, communication is literally a matter of life and death. You need a network that can just appear. And that incredible technology that makes it happen is exactly what we're going to dive into right now.
So what is this tech that makes it all possible? This brings us right to the heart of what a mobile ad hoc network actually is.
Okay, so a MANET is basically a bunch of mobile devices. Could be phones, laptops, anything really, that just decide to create their own network on the spot. Now, the most important word here is decentralized. There's no main hub. Instead, every single device, what we call a node, is both a client and a router. It's forwarding data for everyone else. It's a network with no single point of failure and no central command. Truly, no boss.
The easiest way to wrap your head around this is to compare it to something we all use every single day, your Wi-Fi at home. With Wi-Fi, everything talks to that one central router in the corner. If that box dies, your whole network is gone. Poof! In a MANET, every single device is the router. Your home Wi-Fi has a fixed, predictable map. A MANET, its map is completely dynamic. It's changing every single time a device moves.
So what does this actually look like in practice? Well, it all comes down to these key traits. First, the topology, that's just the fancy word for the network map, is dynamic. It's always changing. It's also self-configuring, which means devices can just join or leave the network whenever they want. No IT guy needed. It just figures it out. And to get a message from one side to the other, it uses multi-hop routing. Your data literally leaps from one device to the next, until it reaches its destination. And what's crazy is, all of this has to work on devices that are probably just running on a battery.
Okay, so the theory is pretty fascinating, right? But where are these things actually being used? Let's check out some of the real-world spots where MANETs are more than just a cool idea. They are an absolute game changer.
And the variety here is just incredible. For the military, a network with no central hub is a huge advantage. There's no main target for an enemy to take out. In disaster relief, it means you can have a communications grid up and running in minutes, right in the middle of a disaster zone. Or think about huge sensor networks spreading thousands of little devices across a forest to detect wildfires. You can't set that up manually. But it even works on a small scale, like you and a few friends starting a quick network at the park to share some files.
Now, as you've probably guessed, trying to create a stable network that's always changing, has no leader, and is full of battery-powered devices, well, it's not easy. In fact, there are some really tough challenges to overcome.
First off, routing is a complete nightmare. I mean, how do you find the best path for your data when the roadmap is being totally redrawn every few seconds? Then there's security, and this is a massive one. With no central gatekeeper, how do you stop a malicious device from just joining in and messing everything up? And it gets worse. As more devices join, the network can get super congested and just slow to a crawl. And finally, if your phone is busy forwarding everyone else's data all day, your battery is going to die fast.
And that security problem really cannot be overstated. The very thing that makes a MANET so awesome, its openness, is also what makes it incredibly easy to attack.
So let me make this real for you. There's something called a black hole attack. A malicious device joins the network and starts shouting, "Hey everyone, I've got the fastest way to get your data anywhere you want." So all the other well-meaning devices start sending their data through it. But instead of forwarding the information along, the bad device just deletes it. Everything just vanishes into a black hole. Okay, so when you look at all these massive challenges, the routing chaos, the security threats, the dying batteries, you have to be wondering, how on earth do these networks even work at all? How do the devices figure out where to send anything? Well, this is where we get into the rules of the road.
I mean, this really is the million-dollar question, isn't it? If your destination is 5 hops away, and any one of those 5 devices could just get up and walk away at any second, how do you ever build a reliable path?
The answer really comes down to 2 main strategies, or what we call routing protocols. You could either be proactive
Or you can be reactive. Think of it like this. The proactive approach is like having a live, constantly updating GPS map of the entire city running on your phone at all times. The reactive approach is more like only asking for directions when you actually need to go somewhere. So with a proactive protocol, every device is constantly chatting with its neighbors, sharing updates, and trying to maintain a perfect, up-to-the-second map of the entire network. The huge advantage here? When you need to send something, you instantly know the best way to get it there. The downside? All that constant chatter, that overhead, it eats up a ton of your battery and bandwidth.
Now, the reactive or on-demand strategy is the total opposite. A device running this way doesn't bother keeping a map at all. It just chills out. But as soon as it needs to send something, it broadcasts a message like, "Hey, anybody know how to get to node X?" And then the other nodes work together to figure out a path right then and there. This saves a ton of energy, but the trade-off is that little bit of delay, that latency, while you wait for the network to find the route.
So we've gone through the what, the where, and the how. Let's zoom out for a second. Why are these self-organizing networks such a big deal? Why does all this matter?
The really crucial idea here is that MANETs represent a fundamental shift. We're moving away from centralized, controlled systems to something that's decentralized and, well, autonomous. We are talking about networks that can literally appear out of thin air, adapt to a completely chaotic environment, and even heal themselves when parts of them disappear. They are resilient by their very nature. And that resilience is exactly why they're so priceless in a disaster zone or on a battlefield. They're built to work when everything else has failed.
And that kind of leaves us with a pretty fascinating thought to end on. This whole principle of decentralized self-organization is incredibly powerful. Today, we're using it to build communication networks in impossible situations. But if our networks can learn to organize themselves, what else can?